Right. So in this class, we're going to be looking at indices. So what are we trying to achieve at the end of this class? So at the end of this class, you must be able to, when you look at the word indices, you must understand what that word means, and you should provide what a definition for that. Then you must also understand the the rules of indices, or the laws of indices. We'll then further look now at the other part which we're looking at today, which is logarithms, be able to define and also look at the laws and also being able to apply those laws. Okay, so what comes to mind when you think about indices? So you see here it says indices or exponents show how many times a number, which is the base, that number we're calling the base, is multiplied by what? By itself. So it just shows how many times a certain number, or which is the base, is being multiplied by what? By itself. So if you have, let's say, 2 to the power 3. So what is 2 to the power 3? 2 to the power 3 is just 2 by 2 by 2, like that. So it means this here is what is, this here, the exponent. Uh, the exponent there is what is the index, because it's showing us what, how many times 2 is multiplying by what? By itself. So it means the base here, which is our number 2, is multiplying itself what? 3 times. Hence the 2 multiplied by 2 multiplied by 2. Thus, in general, we are saying that it just shows us, if we have a number, we're saying any number a to the power n. So this n here is what? N times that you can what? Multiply the a. So it's just a by a by a, just like that, n times up to a. So n what? N times, like that. So that's what basically what indices are, or exponents what are. But then there are these laws, or what, or rules that we apply to indices that make our work very easy, that we're able to what? We're able to solve. Okay, so the first one is the product rule. So for the product rule, what it's just saying is, you see it here, that when you have uh, you have you have numbers. So you have a number, let's say a raised to the power m, multiplying by what? A raised to the power what? N. So if they have the same base, you're multiplying these indices or exponents. If they have the same base, what you do is you keep the base, and then you get the exponents and just add the what? The exponent. So you just add m plus what? Plus n. So this is what the product rule is saying. So let's take an example. So if we have, let's say we have 2 to the power what? 2 to the power 5 multiplied by what? 2 to the power 3. So here what we're going to do is we keep the base, which is 2, then we get the exponent. So you have 5 there, and here you have what? You have 3. So this here, when we add there, we have 5 plus 3 just gives us what? 8. So this is what the product rule is what is saying. And of course, you can evaluate this here. So what this means is just 2 is multiplying what? It's by itself 8 times. That's 2 multiplied by 2 by 2 by 2, like that, up to what? Up to 8 times. So you put the other ones that should be there. Okay, so that's how what this product rule means. And then when you look at the next one is the quotient rule. So the quotient rule, same kind of similar, where you say we have a number a, which is our base, raised to the power m. That's our exponent m. And then you have a to the power n. So this here is the same as keeping the base, that is n, a, and then getting the one in the numerator, that is m. Then we subtract from the one which is what? In the denominator, and that exponent there. So this is what is telling us. So using our same example of 2, so if we say 2 to the power 5 there, divided by 2 to the power what? To the power 3. So this here is going to be 2, that's the base, keep the base 2, then you get the what? The exponent of the numerator, that is 5, then you subtract the one which is what? In the denominator, that's minus what? 3. And you see that this here is going to be 2 to the power what? 2 to the power 2, because 5 minus 3 is just what? Is just 2. So then notice that this here, we can check this, that indeed this is the answer. How? Let's say you have, we write it here. So 2 to the power 5 is just 2 by 2 by 2 by 2 by 2, like that. 1, 2, 3, 4, 5. Then down there, it's 2 by 2 by 2. Okay. Then it means this here goes with that one. This one goes with this one. This one goes with what? That one. Then you have 2 by 2. So meaning you just have 2 times 2, which is just 2 to the power 2, which is what we found there. So this is what this rule is saying. Right. Let's move on to the next rule. So the next rule which we have is this one here. It's saying power of what? Of powers. So if you have, it's just saying a, you have a base m raised to the exponent m, and then you're multiplying it by what? Another exponent here. This here is just going to be a. The m and the n will just multiply, so it becomes mn. Okay, so we go back to our example where we're saying 2 to the power 5, and then let's say our n is 2. So this law just means you keep the base, which is the 2, then you multiply the exponent. So the 5 multiplied by the 2, that will give you what? 10. This is what this law is saying. Right, then the next law that we have is saying a to the negative power, like that. This here is just going to be what you say. If you have a negative power there, you just say 1 over, then you remove, when you say 1 over like that, you remove the negative, and then you just say a to the power n. So taking again example, if you have 2 to the negative 1, this here is going to be what? 1 over 2. Then the 1 here becomes just, you remove the negative, it becomes like that 1. But 2 raised to the power 1 is just what? It's just 2. So you have what? Half, like that. So this is what that law is saying. All right. Let's look at the next one. So the next here is telling you that you have a to the power 1 over what? Over n. Then this here is the same as you writing the square root of. So what is down here is going to be what? Your n. So you write your n there, and then you write the base inside, and then here you square what? To the power 1, like that. So you see, since it's raised to the power 1, you just get the square root of the nth root of what? Of a, like that. That's what it's saying. Okay, now let's take an example. Let's say we have 9 to the power what? To the power 2, like that. So what this means is you have the square root. Since if there's 2 here, it's going to have a square root. So for the square root, you don't put what? You don't put any value here. You only put for 3 going what? Going up. So anything greater than 3, that's when you indicate there. So here you're going to have, so there, that's 2, original square root, that's 2, then 9. So the square root of what? 2, and then it's raised to the power what? The power 1. So which is just the same as you leaving it the way it is. So this is now going to be what? To be 3. Okay, so let's say we have 8 to the power 3. What is this going to be? So this is going to be now the cube root. So here you put what? You put a 3, since it's equal to what? To 3. So we said 3 going up, that's when you indicate. So here, and then you have 8. So now, what is this number? So this number is just telling you what number can you multiply 3 times to get 8. So that is 2 by 2 by what? By 2. Can multiply this 3 times, it gives me what? It gives me 8. So the cube root of 8 is just what? 2, like that. So that's what this means. Okay, then it continues going just like that as you increase the water numbers. Now, let's take an example. What if we had 2 here? What would we have done? If we had 2 here, what would we have done? So if we have 2 there, what we would have done is here would have then put a 2 outside. So that means this part here also is going to have a 2, like that, such that the cube root we found to be 2, but then there's a square here. So 2 times 2. So this is just 2 to the power 2, which is 2 by what? By 2. This here is now going to be what? To be equal to what? To 4. So 2 by 2 is just going to be equal to 4. Okay, so that's what we get. Okay, are there any questions on the laws of these indices before we look at anything further on? All right, so I guess there's no question. Now let's look at something. Let's look at a question or questions that will help us to practice this. So we have these two questions. We have these few questions that are here. So now let's solve Let's solve these questions. So the question is saying evaluate. So evaluating 27 to the power 1 over what? Over 3. So what are we going to do here? From what the concept we're just from looking at? What are you going to do?
We are going to introduce the roots.
Okay, so we're going to introduce the root. So that means this here is just going to be, as you have said, introduce the root like that. So since here there's a 3, meaning the 3 will come here, right? And then you have what? 27 there. So now what is the cube root of 27? So the cube root of 27 is just saying, what number can I multiply by itself 3 times that it give me 27? And you know that's 3. So 3 by 3 by 3 gives you what? 27. So this here is going to be just equal to what? To 3, like that. So that's our what? Our answer. Okay, next we have 256 to the power 3 over what? Over 4. Power 3 over 4. What is what we're going to do here? So we say this is going to be, there's 4 here, so to be 4th root here of what? 250 what? 56. And then outside there's what? There's 3 here, so I'm going to cube that there. Okay, and then I'm going to have the 4th root. So a number that I can multiply 4 times, that will give me 254. So 4 by 4 by 4 by 4, that's 4 times. You give me 254. So if I multiply 4 by 4 by 4 by 4, 1, 2, 3, 4. This here is going to give me the 256. So meaning that the 4th root of 256 is just what? 4. And then you have a 3 there outside. So that means 4 to the power what? 3, which is 4 cubed. This here is just going to give me what? 64. So multiply 4 3 times, you just get 4 3 times by itself. That's, you're going to get what? 64. All right, so that's how you do this one. Let's move on to the next one. So next we have 32 negative what? 2 over what? Over 5. So this here, what are we going to do? So we say, let's write this in standard form, where we say 1 over, we want to get rid of the negative power. So we say 32, then since we said 1 over, meaning the negative cause, and you have 2 over what? 2 over 5 remain here. Then we say 1 over, here we say the fifth root, because there's 5 down here. So that's going to be the 5th root of what? 32. So that's going to be 5th root of what? 32. And then there's a 2 there, so we're going to square it like that. So what's the 5th root of what? Of 32. So the 5th root of 32 is just 2. So if you multiply 2 by 2 by 2 by 2 by 2, 1, 2, 3, 4, 5. This gives you what? 32. 2 by 2 gives you 4. 4 times 2 gives you what? 8. 8 by 2 gives you 16. 16 by 2 gives you 32. So that's 32. So the 5th root of 32 is just 2. So we get 2 here, and then there's a square there. So this is just going to be 1 over 2 squared. That's just 2 by 2, which is what? 4. So here we're going to get 4 or 1 over what? 4 as our answer for that one. Okay, so that's how we calculate. Next. Okay, so next we have 64 over 1849, like that. And then you have half there. So here, what we're going to do, we're going to apply the law of indices. which allows us to distribute these exponents to each and every term here. So you distribute the one in the what? In numerator and in the denominator. So you get 64, 1 over 2, like that. Then you distribute down there. That's 1489 over the what? The half. Then you can write now here. So the square root of what? 64 on top. Since there's 1, we just write it like that. And then there, square root of 1849. So you can punch this in your calculator. You see that the square root of 64, that's just 8. Square root of 64, that's 8. And then we have square root of 1849. That's going to give us what? 43. So this here is our what? Is our answer. Okay. Are there any questions?
No, sir, it is clear.
Okay. So thank you. Let's do now this one. So how are we going to simplify? So now they're telling us to simplify this. You have 3 to the power 3 minus 2x, like that, multiplied by 9x plus what? Plus 2. So how do we do this one here? So first of all, do you have any idea how we can simplify this?
We are going to make both sides the same basis.
Okay, so we make both sides have the same what? Basis. So that means here, and of course the lowest base, right? Since here 3 is our lowest base, so we go with 3. So we say 3 to the power, so this is 3 to the power, this whole thing here, which is 3 minus 2x. That one I will leave it the way it is, like that. Then multiplied by, so I change this base here, the one which is what? 9. So I'll say 3 to the power, we say 3 to the power what? The power 2. So 3 to the power 2, of course, it's then multiplying by what? This here, which is the x plus what? Plus 2. So 3 to the power 2 is what? Is 9. Since, 3 multiplied by 3 gives you 9. Okay, like that. So now we have the same base. I can now distribute this 2 here, I can multiply throughout. So let me first write this side. So 3 minus 2x, like that, multiplied by 3. Multiply the 2 by the x, there you get 2x. And then 2 multiplied by 2, that gives you 4. The next, what you do is you keep the what? The base. So we keep the base, that is 3. The base is 3. And then you add what you have in the what? In the exponents there. So you add those exponents. So you have 3 minus 2x. You're just saying plus what? The 2x plus 4. 2x plus what? Plus 4. You're going to add that. So this is going to be 3. Okay, so negative 2x plus 2x, this will give you 0. And then you have what? 3 here plus what? Plus the 4 there. 3 plus the 4 remain. So this is going to be 3. 3 plus 4 is just what? 7. And what is 3 to the power what? The power 7. So 3 to the power 7, you punch this on calculator, just get that you have 2,180 what? 87. So this here is going to be what? Our answer. Okay, so that's for the first one. Now we do the next one. Okay, so the next we have 5, 2 to the power what? To the power x, and then multiplied by 25 to the power 2 what? 2x. So yes, again, here we're going to what? To make the base the same. So the base, to make it the same, the lowest base we have here is what? Is 5. So we use 5. So you say 5, 2x this side, multiplied by, here I'll say 5 to the power what? To the power 2, multiplied by the what? The 2x there. So this is going to be 5, 2x multiplied by, so 2 by 2 there gives you what? Gives you 4. So you have 5 to the power what? 4x. Then this here, we keep the base, which is just 5, and then we add the exponents. So you have 2x plus what? 4x. So these are the same what? So we can just multiply them, and then we just have this, we can add them. So 2x plus 4x will give you what? 6x, like that. Okay, and here, since this is multiplication, I can say 6x can write this like that, according to that law which I learned earlier. So this here, this and that are just the same. Okay, so now this, what is 5? So 5 to the power 6 is just, so 5 to the power 6 is 1,000, is 15,000, and 15,625, like that. So this is going to be what? To the power x, which is here, the x, because the x has what remain. Okay, so this is what we get as our what, as our answer there. Okay, let's go on, do the next one. So the next one, what are we going to do? So here we have 4 and negative 3 to the power 2x, then multiplied by 8, 2x plus what? 2 multiplied by 16, 3x minus 1. So to what base are we going to put this one? Since we have different here, you have 4, you have 8, you have 16. Which one are we going to use?
We can use 2.
We can use 2. Okay, yeah, that's right. So we can use 2 here. So let's use 2. The first one here, we say 2 to the power 2, which will give us what? 4. And then we say negative 3 over what? 2, like that, multiplying. And then next, you have 2 here to the power what? To the power 3. Then you have 2x plus what? Plus 2 there. And then the next one, you have 2 to the power what? To the power 4. And then you have 3x minus what? 1. So this is going to be, so this 2 and that 2 there, they can what? Divide. And then you remain with 2 to the negative what? 3 there. Then multiplied by, and next you have what? 2. Here, the 3, you can distribute the 3 such that 3 multiplied by 2x, you get 6 what? 6x. 3 multiplied by the 2 there is going to just be plus what? 6. Then multiplied by 2, here you have 4. So 4 multiplied by 3x, you get, that will be 12x. And then 4 multiplied by the negative 1, you get negative what? Negative 4. Then we can what? We can add now. So we keep the base, which is 2. Then we say negative 3 here, plus what? Plus 6x plus 6. Then you have plus the 12x, then minus what? The 4. So this is going to be 2. Now we add 6 plus 12. So 6 plus 12 there is just going to give you 18. So you have 18 what? 18x. And then we add the numbers here. So you have negative 3, you have 6, and you have what? And negative 4. So negative 3 plus the positive 6 gives us what? 3. And then 3 minus 4, this here is going to give us negative 1. So we just have negative 1 what? Remain. So this is how it's going to simplify to what? To this. Okay. Unless there are any questions. Okay, so there's no question. So let's move on now. We're going to now move. We've looked at the indices. Now let's look at what? Logarithms. So now, logarithms, what do they tell us? So if we have a to the power n equal to b, then the log of base a of b is equal to what? To n. So the logarithm tells us about the what? About the power. It tells us about the power. So for example, if we have 2 to the power what? To the power 3, then is equal to what? To 8. So when you're writing the log, so log, let's say log, this base that you have is going to be what? Your base. So your base is what? It's 2. Base 2. And then it's log of what? Now it's going to be log of 8 equal to that there is the exponent there, which is what? Which is 3. So you equate the exponent, which is what? 3. Thus, we're saying that the log tells us about what? The power, because here, what you're equating this 3 here is the power which what you had here. So that's what the log tells us what? About. Okay, now let's rewrite this what? This following in the form. So they're saying rewrite the following in what? Exponential form. Rewrite the following in what? Exponential form. So you have, so write log, you have log base 5 of what? 25 is equal to what? To a. Okay, so how do you write this in the exponential form? So this is going to be the base that you have there is the base which you're going to get. And then this answer here, he said, is the what? Is the power. So that's going to be your power A. And then this here is going to be what? Your answer, which is 25, like that. So we've written it in the what? In the exponential form. They didn't tell us to find A or anything. You just said write it in exponential form. So that's how you do it. You'd write this one. Okay. Next, we have log base 4, 60 what? 4 is equal to what? To x. So this, rewriting it, the base is what? 4. The exponent, which is the answer there, is going to be x. Then this here is going to be equal to the value there, 64. We've rewritten it. Then the next one, you have log base 6, then w is equal to what? Y. So the base there, 6, the answer, y, and then what we're equating to is just w. Just like that, you've written these in what? Exponential form. Okay, are there any questions on how we do this? Okay, so since there's no question, we move on to the next part where we're just going to look at what the laws of these logarithmic of these logs. So what are the laws that are there? So the laws that are there is when you're adding, so we can add actually, we can add what? These logs. So if you have logs of the same base, of course, you can add them. So log A plus log B, like that. So if it's just log A, and then they haven't given you the base there, meaning the base is what is 10. So they don't indicate if the base is what is 10. So they just see it as log A or log B, like that. So when you have log A plus log B, this here, log A plus log B, is the same as you saying log what? Log A multiplied by what? By B. So you multiply the A and the B to keep with to one log. And then the quotient law is, so here what you do when you're subtracting log A, log B, you just say log and then you divide. So A divided by what? By B, like that. That's what this one is saying. Then the next one is here, which you have. So if you have log A to the power n, like that, this n you can drop it in front. That's n. And then you say log, then the A becomes like there, like that. Okay, so our base, as we said, if the base has not been indicated, it means the base is what? Is base is 10. Okay, other ones include this one here, which is log of base. Let's say you have base B of what? Of 1 is always going to be what? To be 0. So it's equal to 0. Log of 1 is what? Is equal to what? To 0. And then log, where you have the base and the value here, the B here, are the same. So if you have 2 to the 2 like this is always going to give you what? 1. This is what this one is saying. Log base 2 of 2 is equal to what? It's going to be equal to 1. Okay, so this one we won't look at it in this class, but we'll look at it in a further class. All right, now let's practice what we've learned on this question here. So the question is saying you have these two questions. We have log, the base is what? 3, and then you have 24 plus log base 3, 15, then minus log base 3 what? 10. So the base, of course, is the same. So you can what? You can proceed. Now, here we have this, what we said when you're adding. So here you see they're adding. So what we can do is we keep log base what? Base 3, and then we multiply. So you get 24, the 24 here, multiplied by what? The 15, multiplied by 15 there. Then minus log what? Log base 3, then 10. So what is this going to give us? So this is going to give us log base 3. So 24, you can punch that. 24 multiplied by what? 15. So that there is going to give us 3 what? 360. So you get 360. So this here is going to be 360. Minus, then you have log what? Log base 3 of what? Of 10. So now here, you see, we now have to apply the one for what? For subtraction, where there's minus. So if there's minus, we resort to what? Making a quotient like that. So this is going to be log base what? Base 3. And then you say this one which you have here, that's your A, that's 360. Then divided by the one which you have there, which is your what? Your 10. And this here is going to be log base what? Base 3. So 10 divided into 360, you just get what? 36. So our value there is going to be what? It's going to be 30 what? 36 here. You're going to have what? This log 3 what? 36. So the question here just requiring us to simplify it like that. Okay, next we do the next one. So the next one, simplifying also, that's just log 2 of what? 98 minus log base what? 2 of what? Of 30, like that. And then plus log 2 of what? 15. So this here is going to be the first one here. You have log base 2. So here, since there's minus, so we are going to form the quotient. That is 98 over what? The 30. 98 over 30, like that. Plus log 250, 15 there. So what is this? 98 over what? Over 30. 98 over what? Over 30. So what is 98 over 30? So here I can just simplify it, the base. 98 over 30, I just get what values can go into both. So 2, so 2 into 48, that gives us 49. 2 into 30, that gives us what? 15. So that's what we get. And then we say log base 2, 15. So now here, since we are adding, so we just multiply. We say log base 2, then we multiply the 49 over 15 multiplied by what? 15. So this and that one, they are divide, and then you remain with log base 2 of what? 49. Okay, just like that, you would have simplified that one. All right, are there any questions? Okay, since there's no question, this is where we end with our class, and we'll see you in the next class.